Okay, so welcome everybody for this final session of the IMS stream for this GSE Conference 2021. So this session will be on the good, better and best. Are you buffering IMS efficiently? And will be a video format, and Susie Wendler will be, and Dennis Eschelberger will be available for questioning and answer session at the end. And essentially we'd like you to post questions in the chat room if you think of them during the session, and then we can field those at the end of the video and slides, and we can see whether Susie and Dennis can answer those questions. Now, in terms of format of this, we've, I said it's a video, we've got feedback. So there's a QR code at the bottom left hand of your screen. So we would urge you to go follow that link and then do feedback and fill out the feedback form for this particular session after the session finishes. That would be fantastic. Alternatively, if you don't have the QR code, then you can go onto the avocado green agenda box on the agenda on the website, and if you click on the title of this session, then you'll get a link to the feedback as well. So essentially what I need to tell you is that this session, even though it's a video, we are actually recording this session, so just bear that in mind. I have to say that. And we have a raffle, which if you want to get some great prizes, then you can do some Just Giving page on Virgin website, and it's a link from the agenda is on there as well, and that's for Guide Dogs for the Blind and National Lifeboats. So that would be welcome if you could enter that raffle. So in terms of the speakers, so we have Susie Wendler, and she is an IMS expert from the Washington Systems Center, IBM, and she's done lots of major work, so critical situational analysis, design implementations for IMS connectivity, and supporting a lot of projects at the moment for the API economy. She's had a wealth of experience and has done many workshops and conferences, etc. in the past. So she will be introducing the first the actual video session itself, and then we have Dennis Eschelberger, and he's a esteemed mainframe, very experienced person. I think he's had over 45 years experience in mainframe, and he's currently sitting, I think, not necessarily working in the same team as Susie, sorry, but certainly works in the Washington Systems Center as well. So they will be able to answer our questions as we go by. But as I said, if you post the questions via the chat, and then we can echo them out at the end of the video and slides. And without further ado, I'll hand you over to Susie.
Thank you, Dominic. Appreciate that introduction. And thank you from both myself and Dennis and Rick. And another thing, we put our emails on the title page, so you can always email us, down the road in a couple of weeks whenever you have further questions. So I'm just going to go ahead and start right now.
Welcome to Good, Better, Best. Are you buffering IMS efficiently? Your speakers today are myself, Susie Wendler, followed by Dennis Eschelberger, and wrapping up will be Rick Engel. Before we begin, I'd just like to remind you to please consider supporting the GSE UK charities, and you will be entered if you do so in the 2021 charity raffle. There is information on this visual, and by following the link below, you will be able to find out more information about how to provide support. Now to the presentation. Since buffer pool tuning is both an integral and, in many cases, an easy way to improve your overall IMS system performance. Our focus will be on 3 capabilities: the IMS Monitor, the IMS Performance Analyzer, and the IMS Buffer Pool Analyzer. Let's first discuss the IMS Monitor and why this is good. The Monitor is an IMS engine-provided utility, which means that it is available to all your IMS environments and can be used when you notice slowdowns, which oftentimes means that performance is compromised. It can also be used periodically to get profiles of your system. They can be used for comparisons as your environment changes. Although the Monitor provides comprehensive information about the system environment, our focus today will be limited to database buffer pool usage. Also note that the Monitor is intended to provide a snapshot or limited time view of your system. Some considerations include that the Monitor has to be turned on and off by command, and this could impact system's performance while it is running, which is why it is only turned on for a short period. Also remember that depending upon the size of your Monitor data set, trace data could be compromised if the output data set is filled. Once the Monitor is turned off, the IMS Monitor Print Utility DFS UTR-20, as shown at the bottom of this visual, will need to be run to format and print the results. Let's look at an example of an IMS buffer pool report. I won't go through all the fields in the report. I will simply point out some areas to look at. These are numbers that can be used in further analysis and can be used to create a spreadsheet, which we will get to shortly. The question we are trying to answer is, what is the right number of buffers for a buffer pool? We want enough buffers so that we can minimize the number of rereads of the same block or CI, and we don't want to waste space for buffers if extra buffers don't eliminate reads. On the upper right of this report on this visual, the first red arrow points to a subpool ID. The buffer size also, which is in this case is 8K, and the total buffers in this specific subpool, which is 800. Note that this is an OSAM pool, but the report for VSAM would be similar. The next 2 red arrows point to the number of calls where data was already in the pool and the number of read IO requests, 2 important pieces of information. I point these out because they are numbers that we will use in an analysis spreadsheet. One number that is also of interest is the number of buffer steal requests which waited for buffers. This is an obvious indication, if it's more than 0, that the buffers allocated to this pool are inadequate. I will discuss the quotient at the bottom of the visual shortly. So let's discuss how to use the buffer pool numbers to gain an insight into their effectiveness using 3 formulas. The first one, the one on this visual, is a calculation of buffer life, also known as buffer residency, which is shown at the bottom of the visual. This is the amount of time that, on average, a block or CI spends in the buffer pool before its buffer is used for another block or CI. Our target is for the data to remain in the pool across iterations with an end user. In other words, their think time. Depending on the environment, the target for this number is in the range of 60 seconds. The value that is calculated from this formula, however, should be used in conjunction with 2 other formulas. The second formula or set of formulas is buffer hit ratio, which has, over the years, been the more commonly documented formula for analyzing buffer pool usage. Depending on whether you have VSAM or OSAM, the formula is documented on this visual. I would like to point out that by itself, oftentimes, a hit ratio may or may not be meaningful. For example, how meaningful is 98.1? Is it good or not? Unless, of course, the percentage is obviously much lower than the upper 90% range, you know, the hit ratio may be a good indicator. Hit ratios are generally more useful when making run-to-run comparisons. For example, if a change is made and the hit ratio increases, it is likely that the increase indicates improvement. The next formula is a quotient that is printed at the bottom of each sample report. A number approaching 1 or greater than 1 is an indicator that more buffers are needed. Note, however, on this visual that the denominator in both cases of total transactions reflects the total number of transactions that were executed during the monitored period and not the number of transactions that specifically use a subpool. So you can kind of gauge how valuable this particular number is depending upon how much this subpool is actually used. So armed with all this information, that is the result of the formulas, as well as the numbers from the IMS monitor buffer pool reports, we can come up with a better perspective of buffer usage. This next visual shows an example of a spreadsheet, one that you would need to set up, or as some customers have done, write a program to read the monitor output and apply the formulas. So looking at the spreadsheet, it contains information from the IMS buffer pool reports, along with the formula calculations that we just talked about. The spreadsheet can be used to gain an overall perspective of your buffer pool usage and how much storage is being used. Then, focusing on the numbers from the 3 formulas, which I've enclosed in the yellow oval, along with an understanding of your environment, you can use the information on this worksheet to guesstimate, and it would be a guesstimation as to whether or not and how much you might need to increase or decrease the buffer definition. These numbers could then be input into the last 2 columns. So overall, the IMS monitor and using the information which you would gather together gives you a good perspective of how your buffers are being managed into your IMS system. I will now turn to the next part and ask Dennis Eichelberger to talk about the IMS Performance Analyzer.
Thank you, Susie. Right now, I'm going to talk about the IMS Performance Analyzer, why this is better. It uses the archived and online log records, so we can get a much longer interval with DC monitor. As Susie was talking about, the DC monitor is usually sporadic and not for a very long period of time because of the daily collection size. So the longer period may provide a better perspective of what's actually happening in your system. We also get expanded reports. It still has the same information, but there's some information that is already done for us, like what she talked about in the manual calculations. Now here's the spreadsheet from an IMS PA run. It looks amazing, like the spreadsheet that Susie had from the DC monitor run. And in effect, it basically is. It's the same system, the same buffering pools, the same subpool ideas, etc. There are minor differences because of the time frame involved. The DC monitor ran about 14 plus minutes, minutes. So it has a small window. The PA analysis report ran about an hour and a half, so we have a larger window to look at. It is basically the same. There's some different smoothing of spikes as we go through, and I'll point these out in the next couple of slides. Here's our IMS monitor report. This is the one Susie had up. It's for the subpool with 8K and 50 buffers. The differences is what DC monitor shows. And we can see in what I've circled in red, number of locate type fields already in the pool at 16,227 as a difference. Now, if we run the calculated percentage on the bottom line here, we show that we actually have a hit of 47.77%. That's off of the IMS monitor. Now, let's move forward and look at the same report for the performance analyzer. Now, like I said before, the DC monitor ran about 14 minutes, and the interval for the performance analyzer is an hour and a half. And we get very close to the same number. It's calculated for us, 49.13 instead of the 47.77. So a longer interval gives us a slightly better, what we refer to as a hit ratio. And now, as Susie said, hit ratios are indicators. they're best used when we do repeated and frequent reports to see the deltas of what improvement or what changes is going on. We may have made no change, but volume did. So that changes the hit ratio. So that's the method of analysis that we use here. This report has detail expanded. It takes a little bit out of the calculations you do not have to do yourself, but we see things like split into per second and per transaction going against this particular buffer pool. So we do have a very good picture here. Let's take a look at IMS monitor against the 800. And we have different things. We get a 33% quotient here, time in the pool, number of transactions that were already in the pool versus the total number of transactions that were used. If we look at the performance analyzer, we get the same report, same buffers again, and we get 38.5%. Very close. We're just using a different interval. But as you can see, both DC monitor and the performance analyzer give you information that you can use and translate that into increasing buffer usages. Here we have blocks written by version. I highlighted that. That's 98% of the operations against this particular buffer pool. And with only 38% hit on locative calls that were already in the pool, this is a very good indicator that we need to increase this pool. Now, every pool is going to be different. Everyone has to be analyzed as an individual pool. Yes, some things may affect changes to those pools that are actually outside of volume, particularly if you change data set block size or data set CI size, then things may need to be changed and altered because those buffers that you were using previously do not really apply to what you just did. These are considerations of any kind of performance that goes on. And remember, always recommend that we do these periodically and check the deltas to see any differences. Let's look at a couple of other things. I talked about logging in the sense that logging is the single bottleneck, single potential bottleneck of any IMS system. There is a logical logger task, which actually does the logging into the IMS log buffers. And then there is the physical logging task, which applies the IO out to it. Now, if there's not enough log buffers and the physical IO task is backed up, the logical logger will wait. There's no space to put what it's trying to log, so it has to wait. And this is where we get into where the IMS monitor shows particular logical logger tasks with latch conflict statistics. What a conflict is someone's already holding a latch. And then someone else comes along and says, I need it. So there's waits. The log latch is used to ensure integrity. It essentially creates a roadblock so nothing can be written that until that buffer is completely written. Otherwise, we lose integrity. When the buffer is completed, the latch is released, and the next waiter can come to it. If we're waiting, IMS could wait. Things will slow down. So this is why we want to pay attention to this. Now, if we look at that in the sense of what the PA report can give you, it expands that. We've got a logical logger highlighted in the second yellow section here. And it shows average per tran of wait times is 27 milliseconds. That's a lot, especially when you're talking about a system that can do hundreds of thousands of transactions a second. This backs up. So the performance analyzer expands this. It counts the number of latch conflicts, and we can see in total that they had to wait and how long they waited. This is a direct impact to your system. This is not related to you from the DC monitor report. So the performance analyzer is better in the respect of giving you more information about things that will slow your system down. How do we see this? All right, let's quick look. We'll back up to the IMS monitor. I do a search on WADS. If you're an IMS person, WADS is the right-ahead data set. You already know that. But I didn't find it in the DC monitor report. It's not there. In the PA report, I find a whole lot of more information about the logger. The performance analyst shows clearly that we need to tune. Why? Here we see check write requests. 4 million out of almost 40 million, 10% check write requests. Every time there's a check write, there's a wait because we have to wait for the parity check to come back from the DASD. Waits for writes, 7. Waits for writes for checkpoint and buffer waits for checkpoint buffers, 7,900. That's a lot for an hour and a half. All of this is shown here. Now, there's a couple of things that I want to point out. Log buffers in red. That number is 5. 5 log buffers for IMS. That's a default for IMS. It's been around since the 70s. It's way, way low. That's an issue. So we do need to increase this. Now, there's a couple of other performance things involved in OLs that would be helpful. And note the block size is 26,624 here. That's great for tracks. It really is. It matches the track size. You get 2 blocks onto a track. However, if we use BD Manager and allocate the OLs as an extended data set, extended addressable data set onto an extended addressable volume, this means we can take advantage of things like HyperWrite if you're mirroring, high performance FICON if it's turned on in your system, and 64-bit buffering to relieve storage so that we can use that storage to increase database buffer sets. See, it all comes together. There's multiplicity of things that we have to look at. 5 is a default, it's way too low. What we should do is go to a 4K buffer, which is recommended 576. That's as close as we can get to a half track. It's pretty efficient. But it also gives us a whole bunch more space where we could go to 64-bit buffering, where we could have more buffers for the logs. A couple of other things to note. Down at the bottom where we see primary watts maximum idle timestamp and old maximum timestamp, these are things that I indicate, well, we do have a maximum, and then we check what is the maximum of IO time. Well, it's not really high, but there have been issues where it has gone over a second. That's horrendous. For any DASD mechanism, taking a second to actually complete an IO is way too high. So this is an indicator that you can go back to your DASD folks and say, at this time, I got this information. Something's going on with the DASD. Let's check it out. So it's as I said, it's a multiplicity of things that you have to work through. This is a good one to do. Real quickly, here's additional comparisons for monitor. We've got bytes of pools, different pools used in IMS, the PSP and the DLI work pools, CSA, eCSA pools. This can be directly related to what is available on the system. This is a good system in the sense that it doesn't show anywhere near the maximum that they have allocated, but it's also not reported in the DC monitor. It's better. Performance analyzer. Now, I just touched on some things it can do. There's a lot of things we can do with performance analysis beyond what I said. We can do ad hoc reporting through guided ASP. That's a forms-based report. You build it. You can make it look like what you want. It's good for management. What do you want to see? Here it is. We can also take input into it. Omegamon, ATF, and TRF records. IMS monitor can be sent into it. IMS Connect journaling can be sent into it. So there's a lot of information that can be gleaned from your IMS system beyond what we just showed you here with Performance Analyzer. And now it's time to stop my recording and let Rick Engel take over.
Thank you, Dennis. We are talking this topic today because one of the most overlooked tasks that the IMS support person can perform to improve IMS performance is IMS buffer pool tuning for batch and for online. But to the lesser experienced or time challenged support person, IMS buffer pool tuning, even with using the DC monitor or the IMS performance analyzer, can be trial and error guesswork as well as challenging. That's why we hear from customers like you see below. They just want something easy to use, something that can tell them exactly what to do. And that's why we invented an IBM tool solution to take the guesswork out of buffer pool tuning, to quickly show you exactly where your buffer tuning opportunities exist and what values to set your buffers for optimal performance. The IMS buffer pool analyzer allows you to properly size and tune your IMS buffers, and you don't even need to bring a whole lot of skill set we need to perform at an expert level. IMS BPA will generate a set of reports that are easy to understand. They will show current buffer usage. They will provide you recommendations, and they can generate predictive reports for you as well after changes are made to existing definitions. There is no direct tie-in to IMS. You capture the data through the use of a GTF trace. There is no impact to running IMS. This is a product that you can set up and use in a relatively short amount of time. Everyone becomes a specialist in IMS buffer pool tuning when they have BPA in their hands. It provides an easy-to-use means to size and tune your buffers. It projects the impacts of changes you might make. No more trial and error guesswork, and the benefits are many. Reduced I/O and CPU, free up overallocation of storage in your IMS subpools, faster batch elapsed times, reductions in online response times, and maybe most of all, think time savings when you compare performing the traditional tasks associated with tuning. So here I begin to show you some of the reporting that is generated. In this example, you see a subpool detail summary, and in this case is for the OSAM 4K subpool. You will see a subpool detail report for each buffer pool that is defined. The report includes actual subpool configuration, actual subpool performance, hit ratio, and then IMS databases with activity in this subpool and the velocity of this activity. This report is a little broader picture, giving you some summary information for all your buffer pools in a single report. Overall buffer pool information, including buffer life and hit ratio. Remember, you want those hit ratios to be somewhere in the 90s. And if they're not, then you probably have a tuning opportunity, and you may want to start looking at the detailed reports for that particular subpool. So here is another report to be aware of. It's the subpool change recommendation report. And if you're the type that just wants something that tells you what to do, well, here you are. With this, you can quickly see exactly where your tuning opportunities exist. The report contains a line for each subpool, what type it is, OSAM or VSAM, name, and current setting in terms of number of buffers defined. In the new buffers column, it provides a recommendation on what the buffer configuration should be set to. Take a look. The new setting might suggest additional buffers, reduction in buffers, or it might show you that the current value is okay. It gives you an estimate of benefit. Take a look at the 8K OSAM line. Here you add buffers, and with it now you are having less reads. You're eliminating I/O, which in turn leads to faster elapsed times, reduced response times. So maybe this might be the first report that you look at that comes out on the buffer pool horizon. Here is another value add that is delivered from the reporting. This one shows databases that are properly defined in the wrong buffer pool, meaning its block size is just not a right fit for the buffer pool it is using. Over time, maybe you have changed block sizes on your databases. Ask yourself, did you remember to change its TBD? It happens. So maybe you can experience some better performance if you right fit your databases into the proper buffer pool. Buffer pool analyzer shows you where your opportunities are in this type of performance. And finally, the last report that I want to draw your attention to is this one, the model configuration report. One is generated for each subpool. In this example, the report is for the 4K subpool, although I notice in this visual that that line has been truncated from the report. IMS BPA does provide predictive analysis, an expectation on what performance will be if you run a certain configuration or buffer pool allocation. You can see that by adding buffers, the hit ratio, reads, and buffer life improve. Key value, though, that I want to point out here is marginal reduction. You'll see this in other reports as well. Marginal reduction is designed to get your attention and show you how hungry a subpool is. When you look at the BPA reporting, searching for your tuning opportunities, you look for the larger numbers in this field. This means potential IO reduction. This particular report, you'll see the marginal reduction reach a point of diminishing returns as well. Pay attention to this as you perform your IMS buffer pool tuning. So how easy can buffer pool tuning be for IMS? Well, I say if you have BPA reporting, all you do when you have it is to start with the sub-pool recommendation report and then look at the other reports for marginal reduction columns. Look for the big numbers. Then you'll know what your optimum buffer pool values are quickly and with no time spent and invested in trial and error tuning. Can't get any easier than this. I finished our session today with a case study from a customer that uses IMS to help run the world. In this case, they were experiencing elongated IMS online response times, and it was impacting their business. Something had to be done. So what this customer decided to do was to perform an analysis of their IMS buffer pools, something that hadn't been done in many years. They used IMS buffer pool analyzer, and as you can see, they ran 26 traces using BPA. Basically 1 trace per hour plus a couple more added in. So this first graph that has been provided shows the impact of the change recommendation made by BPA, changing the buffers from 1500 to 2500 for the 8K buffer pool. Improvement in hit ratio is shown, and we know that hit ratio improvement leads to lesser IO and faster response time processing. Again, here's another graph that was shared with us where they show the impact made to a 12K buffer pool using the BPA reporting. They changed the buffer pool setting from 1500 to 3000. And again, after this change, they see a marked improvement in hit ratio. And the last graph to show you in this session is this one right here. It looks a little complicated to me, but the customer reports that using the BPA reporting, they changed the buffer pool values. And with that, they see improvement in hit ratios, memory allocated. In the end, now they report to us that elapsed times in online transactions improved markedly due to the recommendations provided by buffer pool analyzers. So to wrap this short case study, the customer reported to us that in a short amount of time, they were able to solve their response time issues simply by tuning their IMS buffer pools using IMS BPA reporting to guide and direct them. Tuning your IMS database buffer pools leads to gaining optimized performance in your online and batch processing. Your organization saves costs in I/O, CPU, elapsed times, and response time savings. It is important but often overlooked task with managing IMS systems. Best practice is perform periodic buffer pool analysis to see if changes are in order. We hope you enjoyed the session and maybe learned something new. Thank you for your attendance. And please feel free to contact any of us for any need in your usage of IMS. Thank you.
And before you go, please submit your session feedback form. This session is 7BH. And finally, one more thing. Please consider becoming a member of GSE UK. There is a link at the bottom to contact the membership for details. Again, thank you very much for having attended this session.
Okay, well, thank you, for having listened to this. We just wanted again to remind you that if all you have is an IMS monitor, then there are many good and useful pieces of information in the monitor. And just to remind you that what we tend to do when we analyze your IMS system using just the monitor is to create a spreadsheet to give us a perspective. This is something you would have to do on your own, a manual spreadsheet. But once you've done that, you can keep plugging your numbers in as you monitor your IMS system. And then a better form, if you have it, is the IMS Performance Analyzer, which Dennis showed you what to look at in addition to what you would see in the IMS monitor. And then Rick also reminded you that if you have the buffer pool analyzer, that actually does predictive analytics for you to make it much easier to tune your buffers.
So Susie, can I just ask a quick question? I'm presuming the BPA, that's a separate product, is it? Additional charge product, yeah. Okay.
As is IMS Performance Analyzer.
Yeah. Okay, thanks for that. Okay, so many thanks for doing that slideshow with the video commentary. And I've just opened up for questions. So if anybody, there aren't any actual questions in the room, but basically, as in on the chat session, but basically I've asked everyone to unmute. If they want to ask a question, then please unmute yourself and fire away with your question, because the Dennis and Susie are here to answer those, field those questions. And I've just got a clarification before anybody asks another question, hopefully. This slideshow, I'm presuming that's going to be available so that people can take that away. Is that right, Susie?
Yes. You know, I actually uploaded a video to the GSE UK site. I don't know if it's downloadable from there, but you know, we put our emails up at the front of the presentation. So mine is wendler@usibm.com, and Dennis's is DEICHEL, Deichel at usibm.com. And if for some reason you can't get the slides or the video, please let us know.
Yeah, sure. And I'll make sure it's available, and then hopefully we can, you know, upload it to the site. And you have done so. I'll check that that's downloadable.
Yeah, and I just wanted to make one point. I mean, the reason we did the recording is because we provide you a lot of information across the board, from the monitor to PA to BPA, and we just want to make sure that you have all the information and our explanations of what we're looking at through the video. So I hope you guys can see it.
That's great. So have we got any questions, any burning questions? And please unmute now and you can fire away. Okay, so we'd just like to thank Susie and Dennis for covering those questions. I know we didn't get many, but thank you for everybody in the room and to attend this session. This is the last session of the conference, and it's actually been pretty successful. We've had over 120 people across the 8 sessions, which is not a bad average, over 15, so that's really good. And we've seen some of you on many of these sessions before, so it's great to see. If we have feedback, we've said earlier on about the feedback. If you go onto the agenda website with the avocado color IMS blocks, then you get you can do the link to the actual session itself. So the title, if you click on the title of this session, then you'll get the link to the feedback. So without further ado, I'll just thank everybody for joining this session. We thank our speakers, who some of them got up quite early, like Dennis in particular, and Susie. Thanks for being available to do this session today, and thank you everybody for attending this session in particular, but also the conference overall. So just a virtual round of applause. Okay.
Thank you.
Thank you very much, and have a good rest of your day, and have a good weekend when you can.
All right. Thank you.
Thank you.